simple way to make devices such as car alarms. I'll be going over 3 basic logic gates that explain simple things that you can do such as car alarms or turning on and off a switch that says whether the door is open or closed. And I've been a tutor for a class called Digital Systems for 2 years where we go over things like this, and I've been doing this stuff for over 5 years. And I tend to use logic gates in my train of thought like almost every day, just thinking about problem solving and even just going about my day throughout thinking about social things even. And I'll be going over the history of logic gates, 3 basic logic gates: the AND gate, the OR gate, and the NOT gate. And I'll be giving examples of each of those. According to the PC Magazine Encyclopedia, a logic gate is a collection of transistors and resistors. Jack Kilby was an electrical engineer who invented the integrated circuit while working for TI in 1958. And he was awarded a Nobel Prize in Physics in 2000, according to the Nobel Prize website. The logic gates I'll be talking about are implemented through chips, which can be connected using a breadboard. According to the eSpaceNet patent search, Ronald Portugal invented the breadboard in 1971. So this right here is an AND gate, which is the first logic gate I'll be talking about. And right here, I've written out the truth table for it, which explains the function of it. So what an AND gate does is it takes 2 inputs and sees whether both of them are true. So if both of them are true, then it'll output and say, yes, both of them are true. So this truth table up here is showing that. So it says, okay, I have the key is not in the ignition, and I'm not in park. So my output, I'm not going to start the car. So then here, the key's not in the ignition, but I am in park, so I am also not going to start the car. Here, the key is in the ignition, not in park, so I don't start. And then here, both of them are true, so the output is true. So that's the first logic gate, and you can use that in very many ways. There's not just like one application to it. And then second logic gate is the OR gate. So this says, do I have either or of my inputs? If I do, then the output is a yes. So my application is whether a door is open. So let's say you want a car alarm to go off. So I say, okay, do I have a door open? So my first input is door 1, my second input is door 2. So if either one is true, the output's true. Right here, you see that? You see neither of them are true, so the alarm doesn't go off. And then here, one of the doors is open, so the alarm goes off. Here, one of the doors is open, so the alarm goes off. And then here, both of the doors are open, so the alarm goes off. And then this is the NOT gate. And it's also called an inverter. And the NOT gate is used to say, okay, I want my input to be inverted to the output. So here I have door open inverted to be door closed. So let's say the door is open, so now the output will be, no, the door is not closed. Let's say the door is not open, so the inverted output will be the door is closed. So those are my 3 logic gates. And there's a lot of different real-life applications to use these. So one would be a dryer. Let's say you want to see if the switch is turned to go on and the door is closed, then it'll start. So you would use an AND gate. And then another one is a computer monitor. So you say, okay, I want to know if the keyboard has been inactive or if the mouse has been inactive for 15 minutes or so, and then the screen will turn off. So you use an OR gate to know the computer keyboard or mouse is inactive, and then a NOT gate to invert the screen being on and off. And there's many more applications of these simple logic gates. So I've gone over the history of logic gates, the basic ones that I go over in class, how to use them, how to know what they do, and how to apply them to different situations. And hopefully I've influenced you to problem solve in a more logical way, and hopefully you know more about the subject. And so have fun thinking like an electrical engineer. Thank you.